Welcome to High Tech Channel. Today, we're not just going to watch a house being built. We're going to uncover the engineering decisions behind every stage of the process. Because a beautiful house is only what we see on the surface. Its real strength, safety, and durability are hidden inside layers of structure most people will never see. From the very beginning, the battle against heat and moisture starts at the foundation. Insulation boards are installed beneath the foundation, not simply to keep the floor warm. They also reduce heat loss into the ground and help protect the indoor environment from temperature changes outside. Next comes the plumbing system, routed through the insulation layer. This is where engineers have to think several steps ahead. A pipe placed in the wrong location today can become a major problem once the floor and walls are completely finished. Inside the foundation, a network of steel reinforcement is positioned before the concrete is poured. Concrete is extremely strong in compression, but much weaker in tension. That's why steel reinforcement is added to control tensile stresses and reduce the risk of structural cracking. The red heating pipes are then secured to the reinforcement in a carefully planned layout. The goal isn't simply to make the system work. It's to distribute heat as evenly as possible across the entire floor. Once everything is exactly where it needs to be, the concrete finally goes in. This is the moment when dozens of separate components become one unified structural system. After the concrete reaches its design strength, it will transfer the weight of the house safely through the foundation and into the ground. With the foundation complete, aerated concrete blocks begin forming the walls. Compared with conventional concrete, these blocks are much lighter, reducing the load transferred to the foundation, while also providing valuable thermal insulation. But even the right material can fail if it's installed incorrectly. A thin layer of specialized adhesive is applied between the blocks to create a consistent bond and keep every course precisely aligned. A small error in the first few rows can become a major problem by the time the wall reaches its final height. That's one reason aerated concrete is so effective. It's lightweight, easy to work with, and helps regulate the indoor temperature. But none of those advantages matter unless every block is positioned correctly and the entire wall remains straight, level, and properly aligned. Layer by layer, the thin adhesive joints connect the blocks into one continuous wall system. In a multi-story building, accuracy at this stage matters because every mistake can affect everything constructed above it. Once the walls reach their required height, a reinforced concrete ring beam is formed along the top. It's one of the most important structural details in the house, and one that most people would never notice. Think of it as a structural belt locking the walls together. It helps distribute forces, increases the overall stiffness of the building, and creates a strong connection between the walls and the roof structure. At the front of the house, a timber veranda frame begins to take shape. But this isn't simply decoration. When properly designed, the veranda creates a transition between the interior and exterior, while also functioning as a separate load-bearing structure. At the top of the walls, the insulation and concrete ring beam are completed before the timber members are installed. These members will support the floor system above, which means their position and connections have to be carefully controlled. Large timber beams are then lifted into place on the upper level. Each beam must have the right dimensions and spacing to distribute the loads from the floor and the structures above it. As the roof frame begins to take shape, we can finally see the true form of the house. But what we're looking at is only the visible result of a much deeper structural system designed to carry the load safely to the ground. OSB panels are now installed across the timber frame. They create a continuous structural surface, helping stiffen the roof assembly while providing a solid base for the layers that will follow. Next, the timber-framed walls of the second floor begin to rise. Each vertical member is positioned according to a calculated spacing because the weight of the roof will eventually travel through these studs, into the floor structure, and down toward the foundation. The goal isn't simply to get the wall standing. It has to be perfectly straight. Even a wall that is slightly out of plumb can create uneven loads and cause problems when doors, windows, finishes, and other components are installed. The second floor gradually takes shape. The timber members form the load-bearing skeleton, while every connection becomes part of the path that carries forces from the roof down into the structure below. As the second floor walls rise, the shape of the house changes dramatically, but there's still one major challenge waiting above the roof. A complete timber roof frame now spans the entire structure. It doesn't just define the architecture of the house, it must also carry the weight of the roofing materials, snow, wind, and the forces of nature throughout the building's entire service life. As the roof timbers neared completion, the building finally starts to look like a real home. But from an engineering perspective, this is still just the skeleton. The layers that will determine how well this house stands up to weather are still waiting to be installed. Timber boards are installed across the roof, creating a continuous structural surface. This layer provides the essential base for the insulation and waterproofing systems that will follow. Insulation is now installed across the roof. From an engineering standpoint, the roof is one of the most significant areas for heat loss, so controlling heat transfer here has a direct impact on the home's energy consumption. Above the insulation comes the system of timber battens. These battens create the necessary service space while also providing secure attachment points for the final roofing material. A good roof doesn't just have to be strong. It has to control water, moisture, and ventilation. The joints between the insulation boards are carefully sealed. Even tiny gaps can become pathways for air and moisture, reducing thermal performance and increasing the risk of condensation inside the roof assembly. A section of the roof is opened to create an installation point for the skylight. This is where engineering meets architecture, bringing natural light into the home while maintaining the roof's waterproofing and air tightness. Once the OSB roof deck is complete, the skylights are installed. Any penetration through a roof requires special attention because even a small waterproofing failure can eventually allow water to enter the building. Next comes the waterproof membrane. It acts as an additional line of defense beneath the final roofing layer, helping prevent rainwater from reaching the timber structure below. Finally, the bitumen shingles begin covering the roof. Each course overlaps the one beneath it, following the natural path of water, so rainfall is directed downward instead of finding its way into the structure. The black shingles give the roof a stronger visual presence, but their real value lies beneath the surface. They protect the entire structural system below from rain, wind, and years of exposure to the elements. The overlap between each shingle course is a critical principle. Water will always look for the easiest path through a gap, so every layer is positioned to protect the one beneath it. With the entire roof now covered, we can see the complete defense system: timber structure, roof deck, insulation, waterproof membrane, and the final shingle layer. Together, these layers create a roof designed not just to look good, but to last. But stopping water isn't enough. That water also needs somewhere to go. That's why gutter brackets are installed around the roof, controlling the path of rainwater before it reaches the walls and foundation. If water falls directly against the walls and foundation for years, it can lead to moisture problems, erosion, and gradual deterioration. A well-designed drainage system becomes the first line of defense for the foundation. Downspouts complete the system, carrying water from the roof toward the ground along a controlled path. On the second floor, insulation is installed within the wall framing. The goal isn't simply to keep the house warm during winter, but also to reduce unwanted heat entering the home during the summer. Even in the middle of winter, completing the building envelope requires careful execution. A tightly sealed and well-insulated envelope can dramatically reduce uncontrolled heat exchange with the outside environment. On the balcony, OSB panels are installed to create a rigid and stable floor surface. This is the structural base that must support people, furniture, and the finishing layers above it. But a balcony is especially vulnerable to water exposure. That's why an additional waterproofing layer is installed, preventing moisture from reaching the timber structure and causing long-term damage. Outside, the finished cladding begins to appear. This is the moment when the project starts transitioning from a structural framework into a finished home. Each brick-like tile is carefully positioned. Beyond its visual appeal, the cladding adds another protective layer against sunlight, rain, snow, and constant temperature changes. Precision is what makes the difference. When thousands of small pieces are installed consistently and accurately, the entire surface becomes a stable, uniform building envelope. That's why these tiles are more than decoration. They're part of the home's exterior defense system, reducing the direct impact of weather on the wall assembly behind them. At the base of the walls, a moisture-resistant coating is applied first. This is one of the most vulnerable areas of the building because rainwater, splashback, and ground moisture can affect it continuously. The lower wall cladding is then completed, adding another layer of protection to the lowest part of the structure, the area that often faces the harshest conditions. As the protective film is removed, the true appearance of the finished surface is finally revealed. What was once a collection of protective layers now becomes part of the architecture itself. Timber details are added across the exterior. Wood brings warmth to the design while creating a natural contrast with the harder surfaces, helping the house blend into its surroundings. But every timber element still has to be securely connected. In construction, a beautiful detail only has real value when it also delivers the stability and durability the building demands. The timber frames around the windows are now being installed. These elements serve both an aesthetic and structural purpose, helping create a stable connection between the windows and the surrounding wall assembly. The wood is then coated with a protective finish. This layer helps shield the timber from moisture, UV radiation, and constant exposure to the elements, extending the service life of the material. More timber beams are installed at key load-bearing locations. Each beam becomes part of the structural load path, transferring forces from the roof and upper components down into the main structure. A large timber beam is used as a support for the balcony area. It must carry a significant load, which means the connection between the beam and the main structure is just as important as the strength of the timber itself. The door is finished with multiple coats of paint. It may seem like a small detail, but it makes a major difference in appearance while adding another layer of protection against the environment. The door frame is carefully positioned and installed. Accuracy here affects more than just appearance. Even small errors can influence how the door operates, how well it seals, and how reliably it performs over time. Timber is added above the doorway to complete the architectural design and create a stronger visual entrance. On a well-designed house, these final details are often what bring the entire composition together. The timber members of the veranda are installed one by one. Once complete, they will create a transition space between indoors and outdoors, one that is both functional and closely connected to the surrounding landscape. A protective finish is applied to the veranda timber to defend it against sunlight, rain, and moisture. A quality finish isn't just about appearance. It can significantly extend the service life of the wood and the structure around it. The door and window frames are now coming together. At this stage, the architectural lines become much clearer as natural timber begins to complement the home's modern geometry. Timber details are added beneath the doors and windows, providing both support and a finished architectural edge. They may look like minor elements, but together they help create a consistent and unified facade. Timber railings are installed around the veranda to provide protection for anyone using the space. At the same time, every connection must be strong enough to handle the loads and forces generated during everyday use. On the balcony, the railing system is now being completed. A well-designed railing has to meet two demands at once. It must be strong enough to protect people while remaining refined enough to complement the architecture. The final timber details bring the balcony together. From an engineering perspective, this is where function and aesthetics meet within the same structural element. The timber railing creates a balance between modern design and natural rustic character. It demonstrates an important principle of architecture. Materials don't just determine how long a structure lasts. They also shape how a space feels. The large door frame is carefully moved into position. It's one of the final elements, completing the appearance of the facade, while also creating the home's primary point of entry. Modern light fixtures are installed, adding illumination while improving safety around the home after dark. And finally, after layers of materials, thousands of connections, and countless engineering decisions, the house stands complete among the surrounding landscape. But what we see is more than timber, concrete, and walls. This is the result of a chain of engineering decisions made from the foundation all the way to the smallest finishing detail. Every layer of insulation, every steel reinforcement, every connection, and every waterproofing system has a specific purpose. If you appreciate structures that combine beauty with high-level engineering and precision, please hit like and subscribe to the channel to discover more iconic construction projects.